Here's another rational equation for us to solve. So we need to pick a multiplier that will cancel the denominators. Well, in order to cancel that denominator, I need the multiplier that is the binomial 3x minus 10. But I'll have to multiply this fraction also by that same multiplier, or I would destroy my equation by not having multiplied everything by that quantity. And of course, I'd have to multiply this side of the equation as well by 3x minus 10. But that's not really going to be a problem because that's 3x minus 10 times 0, which is still going to be 0. Now, again, this x cannot be used to cancel that x because this x is tied up in subtraction. So I need a separate factor of x to cancel that one, which means I have to include the separate factor of x here and include the separate factor of x here, so that I'm multiplying everything, each term of the equation, by the same quantity. Now we can do our canceling. Here, the binomials cancel completely, leaving me x times 2x, which is 2x squared. Here, the x's cancel completely, leaving me minus 5 to be multiplied times both those terms. Here's where we need to be careful. Minus 5 times 3x is minus 15x. Minus 5 times minus 10 is plus 50. Equals, any quantity times 0 is still 0. And look what kind of equation we created when we eliminated the fractions. We created a quadratic equation. 2x squared minus 15x plus 50 equals 0. It's a quadratic equation that has all three terms, doesn't it? Second power, first power, constant. And what technique have we said we're going to use to solve that kind of equation? Didn't we say we were going to use the formula? So let's use the quadratic formula. So x equals the opposite of b, so the opposite of negative 15 is positive 15, plus or minus the square root of b squared, that'll be negative 15 squared, minus 4 times a, which is 2, times c, which is 50. All of that divided by 2 times a. That's 2 times 2. So x equals 15 plus or minus the square root of the square of negative 15. And if I remember correctly, the square of negative 15, of course, that's the same as the square of positive 15. And 15 squared is 225. Yes. Looking at my paper just to double check. Minus 2 times 50 is 100. 100 times 4 is 400. All of that divided by 4. So x equals 15 plus or minus the square root of, we have a negative radicand, don't we? The negative radicand tells us we are in the complex number systems, of which this is going to be our imaginary number part. So 225 minus 400, that's negative 175, all of that over 4. Now we should try to see if we can simplify the square root of negative 175. Well, 75 is divisible by 25. And I know that 100 would be divisible by 25. Any number in the hundreds is divisible by 25. 100, 200, 300, 400, those are all numbers divisible by 25. So that whole number, negative 175, is divisible by 25. So x equals 15 plus or minus. Let's see how we can break that apart. That's going to be the square root of 25 times the square root of 7. 7 times 25 is 175, times the square root of negative 1. All of that over 4. So that's 15 plus or minus 5 times the square root of 7 times I over 4. And remember, when you have a complex number solution, you need to express it as the separate fractions. 15 fourths plus or minus 5 times the square root of 7 over 4, I. So this rational equation ended up having the complex solutions that we see here.